Hey guys, happy Friday. We're going to jump into 8.4, solving inequalities. So grab your interactive notebook and your textbook so you can follow along with us. I want to start off with just a little activity though. Okay, here's a number line. Let's say we had 0, 1, 2, 3, 4, 5. Okay, and we could have some negative numbers. Not going to list every single one of them. Okay, and what if I gave every single one of you a post-it note in the shape of a circle, and I said, hey, come to the board and put your post-it note somewhere less than 4. Somewhere less than 4. So let's number 4, 2, 3, here's number 4. So let's say that you went up and you put your post-it note right here. Right? You could put your post-it note right there, sure. And then your neighbor went and put their post-it note right here. And someone could put their post-it note right here, right? Is that still less than 4? Sure is. What if you were smarty pants and you went and you put yours way over on the window, right? Here's the window on the wall, and you like to peek out and see all the buddies and people going down the street and what they're doing in the hallway, or not in the hallway, but in the parking lot, right? Okay, so you could put yours all the way down there. Everything, you could go down the street and run 5 miles and still be less than 4, right? But what if one of you went up and put your post-it note right on the 4? Is that less than 4? No, it's not. That one doesn't count. But couldn't you be right up to that 4? It could be all the way up, really, really close. Just everywhere, as close as you could. In an infinite way even, but just not exactly on the 4, right? Make sense? So if I want to graph some things, if I said graphing x is less than 4, like what we were talking about, if I'm going to graph less than 4, let's see if I can do this here. Oh, I guess I got rid of everything. Okay, let's undo that. Okay, I can't really get rid of that. We're gonna roll with it. Let me erase it that way. Okay. Thanks for bearing with me figuring all this stuff out. Okay, so what I could do is I could say, hey, I want you to know that it is everything less than 4 but not equal to 4. So I'm going to use an open circle right on 4 because that means it doesn't actually include the 4 itself. It's just everything underneath it, and way this way. It could go on this way forever. So I'm actually just going to use an arrow because there's no way that I can sit here and draw forever, right? You would grow old drawing one inequality and have nothing else to do and get pretty bored, right? So this means x is less than 4. Well, what if I said x is less than or equal to 4? Well, now it can equal 4, so I'm going to use a closed circle. Hopefully this is a little bit of review. So let's go ahead and solve some inequalities and then also graph them. Okay, and we're going to have to learn a couple new rules. We're going to start with an example, and then hopefully we can go over some rules and it'll make sense. So let's start by just solving this. Pretend that this is an equal sign. Okay, no, it's clearly not. It's not even an or equals. Okay, but just imagine that we have some sort of inequality, right? If we were actually balanced here, we would want the same thing to be on the same sides. Well, what we're saying with an inequality is actually the opposite. It's not equal. So really my scale will kind of look a little bit more like this because this side is greater than the other side. Okay, so if my left side is greater than my right side, it would be heavier and it would be lower. But if I want to keep it so that it is definitely still greater than, I want to do the same thing to both sides. So I know we've done a little bit of stuff like this, but just a quick reminder, it's still a little bit like a balance. And we're just going to do the same thing to both sides of my inequality this time. So I'm solving for x. I want to get rid of the things that are happening to it. In this case, it's plus 3 and times a negative 4. Remember, it's the inverse order of operations. You have to go backwards. So I have to get rid of the adding and subtracting before I can get rid of the multiplying and dividing. So I'm going to subtract 3 from both sides. Gives me negative 4x is greater than 20. Now I'm still solving for x. Undo multiplication with division. Keep that negative with it. This is going to cancel. Okay, now, before I can, in this, I guess 20 divided by negative 4 is going to be a negative 5. Before I can actually answer this, we have to learn a little rule here. And without going into all the depth of why, negative world is all opposite. Remember we talked about this? Anytime, and make sure you put this in your notes, anytime you multiply by a negative or divide by a negative, you have to flip your sign. So take a minute and write this down. This is really, really important, and really has to do with if you were to take an amount of money that you owed someone and you were to divide it, so to speak, it actually kind of does the opposite. And we talked about that a little bit when we did inequalities in the past. If you had less money, you already owed someone, and you had less, you actually still owed more, and you had a smaller negative number, things like that. So if we had this symbol right now, a greater than, I'm going to flip it and make it a less than. If I had a greater than or equal to, and I flip it, it'll be a less than or equal to. Okay? So those are the differences there. All right, so now I have x is less than negative 5, but I still have to graph this. Okay, so here's my number line. Go ahead and just sketch a number line when you graph these and just put a couple numbers on them. Don't do a ton, but your main number will be a negative 5, right? So you know this is a negative 4, negative 3, etc. You don't have to even put this many numbers on there. Just mostly put the one that you need. And if we're going to graph it, I know that it cannot be equal to negative 5. Kind of like if we're putting our Post-it notes up somewhere, I need all values of x that are less than negative 5. All places you could put your Post-it note that are less than negative 5. So we're going to go this way. And again, not equal to, so we're going to use an open circle to note that. And this would be the correct answer for the graph right here. Okay, so we solved it and graphed it. All right, example 2. What if we had a fraction in here? Can still do the same thing. Here's going to be the line. I do the same thing to both sides. I'm looking for my x, so it's being added to and multiplied by a fraction. So I'm going to undo the addition first by subtraction. So I have negative 3/4 x, and then keep my sign. I haven't multiplied or divided by a negative, so my sign stays the same. Okay. Again, don't worry about writing the line every time and worrying about flipping your sign, unless if you say, okay, multiplying and dividing, do I have a negative? Then check at that point. Okay, so, wow, this far that's great, but I have to multiply, or I have to undo my multiplication here with division, but I have a fraction. What am I going to do? Well, do you remember, if you multiply by a reciprocal, you end up having just the number 1. And isn't that what we want? We want to have 1x left over, or we can write that as just x. So anytime you have a fraction, in order to get rid of that, we have to multiply by its reciprocal to undo all of it. Okay? So we're really getting a 1 here, and if I want it to be a positive 1, how do I multiply to get rid of a negative? Well, a negative times another negative would equal a positive number. So I'm going to multiply by the reciprocal and keep its sign. So I'm going to multiply by negative 4/3 on this side, and I'm going to multiply by negative 4/3 on this side. Okay, this is going to cancel. Now, it doesn't go all the way away. It really just turns into a 1x, right? Which is the same thing. Now, careful. I multiplied. Ding, ding, ding. You should see the flashing red lights, the big alert sign, the crazy things that you drew here should be flashing in your head to say, wait a minute, I multiplied by a negative. I need to stop. What do I need to do? You need to flip your sign. Okay, so over here, if you have any whole number, it's the same as over 1. And I can do a little bit of cross-reducing here before so that I can make it a little bit simpler. If I divide this by 3, I get a 1. If I divide my 15 by 3, I get a 5. And now I just have x is greater than or equal to a negative 20. And I said the wrong thing. No, that's right. Greater than or equal to. It was less than. Okay, so here is my solution, and now I have to graph it. Remember, all you really have to do is put the negative 20 on here, and in this case, I want to use a closed circle because I could put my post-it note on negative 20, and it would still be true. If I told you go put your post-it note up anywhere that's greater than or equal to negative 20, well, you could put it right on there, and that still makes that statement true. Okay, but greater than is actually going to be this way. Okay, there we go. We did that one. Let's go over one more example. We're going to do a skills check, and then I'm going to kind of let you loose here to try these. We're not going to go over all 6 of these examples. If you get some of them, it's the same process. Sometimes you'll have to combine some like terms and things like that. I feel like you guys have been combining like terms pretty well. If you have questions, please reach out. Let me know. But I do think that doing this next example is probably a little bit more pertinent right now because of the distributive property. I think we kind of still miss that a little bit. In order to simplify this, I have to get rid of those parentheses first. So I need to multiply that through. And a negative times this positive gives me a negative. Okay, and now I haven't I multiplied by a negative 2, but I only multiplied one side by a negative 2, so that doesn't count. It's when I multiply both sides by some negative or divide both sides by a negative that I have to flip the sign. Okay, so I just wanted to do this one to make sure you guys realize that. This was technically multiplying by a negative, but only to simplify on one side. This equality or inequality is still the same. Okay, now I need to add 8 to both sides. If you want to draw the line, you can. Negative 2r is greater than 27. And now in order to find r, I am going to be dividing by a negative. You should see the flashing red lights. Instead of it being a greater than, everybody, that's right, it's a less than. Now this is what going to be 13 and a half, I guess. You could write it this way, or you could write negative 13 and a half. I don't really care either way. They're the same thing. Okay, now on your number line, I'm going to put negative 13, and I do want to have a negative 14, and why is that? Well, negative 13 and a half falls right between the two. All right, now I'm going to use an open circle because it was not or equals to, and which way should my arrow go? It needs to be less than. Less than goes down the same. Remember, this kind of looks like a little L. L is less than. Okay, and then if it doesn't look like an L, it's greater than. That's just a quick little trick or tip that I still think about sometimes. Okay, there's your example 3 answer. I want you to try number 1 and 2 from skills check 1. Number 1 and 2 from skills check 1. Pause the video and we'll check them together. Okay, how'd you do? For number 1, you should have gotten... This is what you had to start with. You should end up, if you added 7 to both sides and then divide by 5. If you're dividing by a positive number, there is no need to change the sign. So you should have gotten the answer of x being greater than 2. When you graph this, I did say to graph, right? Yes. So put 2 on here, and we are going to say it's an open circle because it is not or equal to, and I know I did not go over this a ton. That should be review. I hope I touched on it enough. If you need to go back in your notes and kind of check on some of that, please do. Okay, and skills check number 2, you needed to add 8 to both sides, and then you had this funny little, okay, can't write and talk at the same time. Then you had this funny little fraction, so you need to multiply by 3/2, or the reciprocal. Okay, and when you're multiplying by a positive number, no need to flip the sign. You didn't have to flip the sign on either one this time. And you should have gotten n is less than or equal to 6. So here's my number line. I'm just going to put a 6 on there. I'm using a solid dot because I could put my post-it note right on that number and it would still be true. But it is indeed less than this time, and is less than or equal to 6. So it's all of these spots that I could put a post-it note. Okay, I hope that helped you a little bit. Today you have 1 through 19 odd for homework. Try those. Check with the answer key posted in RenWeb, and there's a Desmos activity for you to try if you'd like a challenge activity. Take a screenshot of that and email it to me, and I can give you some extra credit. I hope you have a wonderful day. See you guys soon.